Hello, good morning, good afternoon, welcome. I'm very pleased to be joined by Julio Carpio. Julio is a hydrogen architect for Engie, and as the name goes, he's designing, helping design, solutions and the I guess the technological building blocks for clean hydrogen and its derivatives, the projects to supply those. And he's based in Chile, but has a global remit, helping Engie with its projects and its technical sizing of the different parts of the value chain. So, Julio, it's great to talk to you. Thanks for joining me.
Thank you, Nadim. It's nice to be here.
Yeah, you're going to be down in Santiago speaking at the World Hydrogen Latin America Conference, which is fast approaching. It's 12th to 14th of December. Obviously, a lot of projects currently under development, and you're clearly advising your team, Angie's team, on a number of sort of projects. There's the HyX project, which is a large scale project. Can you give me an idea of the kind of work that you're doing in terms of I guess sort of sizing the projects and what your commercial teams are asking you, and how you going about that? What are some of the, I guess, opportunities and indeed challenges?
Yeah, absolutely. Well, the way I support the team here is to provide some technical background, and first of all, on the, as you mentioned, the sizing of the value chain. So determining the right site where to get the renewable energy, and then identify what capacity of renewable energy we need in order to produce certain amount of hydrogen or an E molecule. In this case, we're aiming to produce ammonia in Chile. And then not only sizing of the renewable itself, but also the sizing of the electrolyzer, the sizing of the uh, um, compression and storage facilities, the transmission type of transmission, what we want to transport. Shall we transport electricity? Shall we transport hydrogen? Shall we transport ammonia? Um, so at the end of the day, sizing a whole value chain in order to get into a final configuration that assures the lowest possible cost of the molecule at the end. Then, as engineering progress, of course, my support is on uh, revising and reviewing all these assumptions behind they meet Engie's requirements and assumptions and in terms of quality, and of course assessing if there is a new uh, technologies coming up that can improve certain aspects as we progress, because this is long-term activity.
Mhm.
Then to incorporate that on time in order to always reduce the production costs.
Yeah, and in terms of the other ways, I guess, to reduce the production costs, you see it bedding in new technology, getting the decision right about what are you transporting? Are you locating the ammonia facility, the Harbour Bosch facility, near the renewable energy plant or near the port, and transferring electricity? I mean, what are some of the advantages, I guess, to transporting ammonia by pipeline, for example, or indeed hydrogen by pipeline, as opposed to using a transmission line?
Well, in a project that is completely off grid, and where you rely on the renewable profiles, either they're solar or wind or both of them, or a combination of both, then you have to deal with that intermittency, and of course, and most of the processes downstream the hydrogen, like ammonia or methanol or others, they cannot ramp up and down as fast as this renewable profile. So you need an intermediate storage of hydrogen. Um, so you, depending on the conditions of the site, then there's a possibility to either transport electricity. You install a high voltage transmission line,
Yeah.
and produce the hydrogen just right next to the ammonia plant, for example, and store hydrogen in order to supply it in a smooth way to the ammonia plant, to the Haber-Bosch.
Yeah.
That's an option, but then you will need, probably depending on your load factor, a really big amount of storage, very large storage of hydrogen. So if you could use a pipeline, for example, to transport the hydrogen, then produce the hydrogen next to the renewables, use a pipeline to transport the hydrogen, and then use that pipeline also not only as a transmission storage, but also as a transmission source, but as a storage facility.
Yeah.
Then you can reduce some of your capex in that way and soften and smooth your production profile. You could then also produce
So
it
you use the
everywhere.
pipeline as the storage, as it were.
You could use the pipeline as a storage as well. Of course, that has some technical challenges that are being analyzed. So there are limits on the operational range. There are limits on the swinging of the pressure that you can do. So the idea is to incorporate all that into a model that can actually set all the constraints that we can have regarding cost, regarding technical aspects, regarding ramp rates, regarding operating pressures, and then the amount of hydrogen you can actually store in a pipeline, and blending that into a model that can actually optimize all that. And that's actually the strength of Engie, where we have a very strong team and the tools to actually assess that particularly well.
Yeah. Yeah. I mean, and I guess then it's about getting the environmental impact assessment as well. I mean, I guess that's also obviously a strict criteria in Chile. And I mean, any comments around how you can accelerate the environmental impact assessment process, or reducing the permitting process?
Yeah, absolutely. We're talking about long-term projects, but they also were quite large in capacity, and they're involve large amounts of land, and we're talking about large PVs, pipelines. We're assessing even different regions, different counties or municipalities, and so the environmental assessment could take quite a long time to perform, and this is key in order to de-risk the projects. It's important for us to have a clear rules on that, but also fair times in order to make decisions on time. Particularly in Chile, this process can take a long time, at least 2 years for environmental impact assessment. And with so many projects at the same time, it could take even longer. So it's important to make efforts to keep those assessments, of course, fair, in order to protect the environment. We don't want to cause any harm.
Yeah.
But also fast enough and in a fair way to help make decisions on time. We're talking about technologies that are changing every month or every year. So if we take too long, then by the end of the process, there is some new technology that could actually improve something, then and then you need to go through the process again. So it's actually quite important to improve those approval times and assessment times for decision making.
And I guess another route to discussion, and certainly I think it's the panel you're speaking at the conference, is around the common infrastructure and sharing ports, and actually even the logistics side as well. What needs to happen there is there needs to be some greater clarity around regulation and policy for shared infrastructure.
This is something that there are within, for example, different the hydrogen, the Chilean Hydrogen Association. There are conversations about this, and all different actors have talked about that. That is okay. By the time these projects become a reality, there will be the ports could be jammed with all the imports of for example, PV panels or wind turbines that will come, on also the electrolyzers, and then the routes to transport them from the port to the site. So there is actually a need to assess and find ways to let the port operate in a smooth way, and even if they need some temporary facilities to be installed at some point in time, even temporary custom offices and on a different side in order to import all that should be assessed. That should be analyzed in order to allow all these imports to happen without affecting the ports, and also the routes to transport all this. That's one key issue for the next years. Then we're talking about the large project will happen. We're aiming COD at the beginning of the next decade. So we're right on time to discuss this. This is the right moment to talk about this and develop the strategies, as well as the common infrastructure. For example, we're talking about transporting hydrogen. There would be a lot of benefits if several companies, even though they're competitors, can actually rely on common infrastructure like pipelines or transmission lines to boost these projects.
Yeah, no, that makes a lot of sense. I mean, and I guess in terms of, we've seen obviously a lot of mention of ammonia and methanol, less so. Is that what are the reasons for sort of less interest in methanol in Chile?
Well, it depends on the what you can find locally. For example, the good thing about methanol is that it's a very easy to handle product. It's liquid and ambient conditions, and there's already a lot of infrastructure around methanol, and there is actually technology to use it as a fuel available right now. The limitations on methanol is to where to source the carbon that you need in order to make the molecule if you're dealing with green hydrogen, because then you need to guarantee the circularity and the net zero of the whole process. So not every source of carbon is suitable for that, and then the north of Chile, of course, you don't have that type of molecule. You don't have that type of source of carbon. Where you can find perhaps in the south of Chile, but not in the tip, not in Magallanes region, but more of the Bio region. So that could be a source of biomass or biogenic CO2. But then you need to transport it to wherever you need it, and so that's another cost on top of it. So ammonia, you only need air to get the nitrogen from it, and which is free. So ammonia, it's easier to handle. It's easier to source or to produce, particularly in the north of Chile. And every region, it's different in that case.
I mean, in terms of I guess other incentives that need to occur. There's specific some ones that need to occur in the Chilean government, or are you expecting more, I guess, clarity for American or EU off-takers, or indeed Asian off-takers, to be able to cover that green premium?
Yes, well, the advantage of Chile has always been the great natural resources, the renewable resources, and some of this existing infrastructure around. However, there are some other countries with policies that can actually defeat Chile if those policies are actually deployed properly. Like, for example, the IRA in the United States.
Absolutely.
And so it's important that Chile remains not only Chile but all Latin America that wants to develop green hydrogen, that keeps on the track to deploy new incentives that can actually help to reduce the cost on one point.
Mm.
So each country has its own capabilities, so they need to see what can be done in order to, let's say, if they can set up special economic zones or some type of other incentives on one side,
Yeah.
or reduce certain type of taxes, import taxes, or income taxes, this type of things, certain fees or anything. But also, on the other hand, to make some regulation to have the clear ways in order to develop these type of projects and reduce the time to develop them.
Yeah. Yeah, reduce the time and therefore reduce the cost. So thank you, Julio. Thanks for taking the time out to share your thoughts with us, some interesting points you've made, and we look forward to you giving further insight into the work you're doing on the hydrogen projects at World Hydrogen Latin America, which, as I mentioned before, is 12th to the 14th December in Santiago, Chile. So many thanks, Julio. Thanks for sharing your thoughts.
Thanks a lot to you, and we'll see you then.
Yeah, we look forward to seeing you there. Thanks a lot. Bye bye.